Hello everyone, this is the method of undetermined coefficients, part 3. Last time we saw how we can't have any duplicates between the complementary solution, which is the solution to the homogeneous differential equation, and our particular solution, which is our guess, to the solution of the non-homogeneous. So the idea is, if you want to find y sub p to make it easier, find y sub c first, and then compare it to y sub p. If there's duplications, multiply the necessary parts of y sub p by the least power of x, so that there are no duplicates between y sub p and y sub c. So to begin with, in this example, we'll write down the associated homogeneous differential equation, which you could probably skip this step, third derivative, plus, because all you're doing is setting it to 0. Get the characteristic equation, so r cubed plus r is 0, factor r squared plus 1 is 0. Set each factor to 0, so r is 0, r squared plus 1 is 0. Since there's no linear term in this quadratic, isolate the r squared. Square both sides gives us plus or minus I. Come up here for the complementary solution. Okay, it's going to be c1, because r0 is real distinct, c1 e to the 0x. And then plus, okay, here we have complex conjugate pair, a plus or minus bi. Recall the solution is e to the ax, so e to the 0x. And then times, we left off with c1, so c2. Cosine bx, b is 1, so just cosine 1x or cosine x. And then plus c3 times the sine of x. Okay, and let's clean that up. Get rid of the e to the 0x's, c1 plus c2 cosine x plus c3 sine of x. Okay, so then we make your guess as to what y sub p should be. And it's based on this function, 2 minus sine of x. So we have a constant term, a, and the sine of x. Now whenever you have either sine or cosine, you don't have to have both, you have to include both. So we'll say plus b sine of x plus c cosine x. And the reason why we have to include both, as mentioned earlier, is because the nature of the differential equation is such that the combination of its derivatives has to produce this function. So these could contain cosines as well. Alright, so then we make a comparison. And we see that there are duplications. So you compare these, and you see there are duplications. That is, the x, or the a, is the same as the constant c1. So we're going to multiply that by x. And consider the sines and cosines together. And we see that they're identical as well. So we're going to have to multiply that pair by x. Alright, so therefore, we're going to take our y sub p now to be ax, and then plus, put this b sine x plus c cosine x in parentheses, multiply that by x as well. Alright, so now routinely we'll find some derivatives. Looks like we have to go all the way to the third derivative here, so this might be a little tedious. So let's see, y sub p prime would be derivative of ax, a, plus derivative of this requires the product rule. So first factor, b sine x plus c cosine x, times the derivative of the second is derivative of x, which is 1, and then plus the second factor x, I'll hold on to that, recopy, or take the derivative that is, that's in parentheses there. So that's b cosine x minus c sine of x, and then times that x we were holding on to. Okay, go to the second derivative. Gonna spread things out here, try to give enough room. Okay, the derivative of a is 0. 1 times these are just those, so then their derivatives b cosine x minus c sine of x, and then we got the product rule in this next term again. So first factor b cosine x minus c sine x, go to the second one again, and then plus the second factor, the x, I'll hold on to it, derivative of the first, minus b sine x, and minus c cosine x times that x. And then I think we can probably combine some things here. In particular, the b cosines and the c sines. So we've got positive 2b cosine x minus 2c sine of x, and then this next term, just recopied. And then finally the third derivative. Okay, so we get minus 2b sine x minus 2c cosine x. Okay, product rule again, once again. Excuse me. So first factor minus b sine x plus c cosine x, that's minus c, sorry. Then times derivative of x is 1, and then plus the second factor, x, I'll hold on to that. Differentiate what's in parentheses there, minus b cosine x, and then plus c sine of x, all times the x. And looks like we can combine again. B sines, C cosines. So we have minus 3b sine x minus 3c cosine x, and then minus b cosine x plus c sine x, all as quantity times x. Alright, so now we get to substitute. And substituting, kind of tedious here to rewrite everything, but y triple prime, because going back to the original differential equation, non-homogeneous, y triple prime was minus 3b sine x minus 3c cosine x plus that quantity minus b cosine x plus c sine of x times x, all is quantity times x. Then we've got plus y prime. Y prime was right here, and so a plus, get rid of these parentheses, b sine x plus c cosine x, and then plus the b cosine x minus c sine x, times x, and that has to equal the 2 minus sine of x. Okay, and what we should notice, like what happened in the last example, is that the terms that we multiplied the power of x by at this stage go away. And you can see that's true because we've got this minus b cosine x times this x going away with this positive b cosine x times that x, and similarly with the c sine of x's. Okay, so at that point, let's combine. Looks like we have some like terms again. We got a minus 3b sine plus a b sine minus 3c cosine plus a c cosine. So minus 2b sine x minus 2c cosine x. Don't forget the plus a, and that's equal to the 2 minus sine x. Okay, so now we can start the comparison. And we're going to compare, let's say, the reals, the constants first. So on the left, all we have is a. On the right, all we have is the 2. So a is 2. Compare the sine of x. And we have minus 2b sine x equaling the minus sine x on the right. So minus 2b equals minus 1. B is 1/2. And comparing the cosine of x, we have minus 2c cosine x equaling, okay, there are not any cosine x's on the right, so 0 cosine x. So minus 2c is 0, and c is 0. So finally, y sub p is, okay, we had ax, a was 2, so 2x, and then b sine x plus c cosine x. Well, c is 0, so that's just b cosine x, which is 1/2, but that 1/2 sine x is being multiplied by this x. So plus 1/2 x sine of x. Okay, so that's it. And they do get a little bit of work involved. I'm going to cut this video short, but I want to show you one thing before we leave this. There's a table of trial solutions posted in Blackboard. Right above the videos, there's a folder with homework with some handouts. And this is what the table looks like. We're going to be using this to make it easier for us to determine what our guess for y sub p should be. So this tells you whatever the function is, it tells you what to use as your guess. So we'll come back in the next video and we'll look at some examples involving these and hopefully finish up this section. If not, it'll take one more part. So we'll see you in a little bit.